Hi everybody, this is Unit 0, which is a lot of algebra, Unit 1. Our first lesson is representing functions. We're going to talk about domain and range and what makes a function a function. First of all, everyone should know that the domain is a set of x values and the range is a set of y values. So we have -3, 0, 1, and 2, and the range we have 3, -7, -5, and 4. This is listed in what is called set notation, and notice it's from least to greatest. All right, next example. This is taking the same 3 coordinate pairs and representing it 4 different ways. So as you can see, we have the order pairs 1, 2, -2, 3, and 0, -3. If I wrote that as a table, if I plotted those on a graph, and I list them as what's called mapping. A function is a relation in which each element of the domain is paired with exactly one element of the range. So this is a function. The easiest way to tell is the x values do not repeat. So as you can see, in all 4 of these representations, my x values are all different. So that is a function. Okay, example 3. Just 1 second, sorry. Okay, now, in each of our 4 representations, we're going to decide, we're going to state the domain and range and then determine if each relation is a function. So notice, there's our domain, and it needs to go from least to greatest. So notice the first value listed is -8, then 6, 7, and 10. Same thing with the range. -9, -2, 3, then 4. So in each set of numbers, they're going from least to greatest. Is this a function? Yes, it is. None of the x values repeat. Every x is paired up with exactly one y. Okay, in our table, here's our domain. 1, 2, and 3. The range, if you look at the y values, I know that 4 is listed twice in the table, but when you list it in set notation, you only list it once. This particular representation is not a function. If I listed these points out separately, I would have 1, 3, and 1, 4. So notice, this x is paired with 2 different y's. Okay, so this is not a function. Doesn't matter that this other y value is a 4. Is if I listed out each one of these points separately, you can see that x is paired with 2 different y values. So this is not a function. Okay. The mapping. Domain, -3, 0, 1, and 5. Really easy, right? Here they are. -3, 0, 1, and 5. The range, -4, -2, 0, and 2. Now let's list these points out. So I have -3 goes with -4. 0 looks like it's paired with -2. 0 is also paired with 0. 1 is paired with 2. And 5 is paired with 0. There are 1, 2, 3, 4, 5 sets of lines. 1, 2, 3, 4. That represents 5 points. Is this a function? No. because the x value repeats itself. Or this 0 is paired with -2, and this 0 is also paired with another 0. So this is not a function. All right, the last is the coordinate graph. There's a couple ways you can do this. You can list the coordinates out first. You could say -1, -1, 0, -3. That looks like 1, 0, and 1, 2, 3, 4, 4, 2. Okay, I can get my domain, least to greatest. -1, 0, 1, and 4. In the range, the smallest one goes -3, -1, 0, and 2. Okay. Domain, range. Is this a function? Yes, it is. None of the x values repeat themselves. Or if you look at each vertical line, which is the x, there's only one point on each vertical line.